Let's find the inverse of a radical function. Now, very much like the vertical line test to test for functions, there's a horizontal line test, and it tests for the inverse and to see if it's a function. The inverse of a function, f, is also a function if and only if no horizontal line intersects the graph of f more than once. Consider the function f of x equals the square root of x plus 2. Determine whether the inverse is a function. We're going to look at a graph and do the horizontal line test, and then find the inverse. So let's move this out of the way for a second. And we have f of x equals x plus 2. Now, what I do know is that the parent graph shifted left 2. The h here is a negative 2 because to begin with it had to start off as a negative minus a negative 2 since the minus is in the formula anyway. So that's left 2. And that just means the parent graph that did this has shifted over left 2. Here is the ordered pairs I tested. In case you want to look at that, take a screenshot and study it, or maybe try working it yourself. If I try the horizontal line test, it means that I'm going to put this line horizontally on this f of x, and if it only touches the line in one spot, and only one spot, then it will be a function. So yes, my inverse will be a function. Now, let's find the inverse. Okay, to find the inverse, the first thing you do is you let y equal f of x. So I'm replacing the y with, or I'm replacing f of x with the square root of x plus 2. The next thing you do is swap x and y's positions. So put x here and y here. Then you solve for y. To get the y out from under the radical, you're going to have to square both sides. The square cancels the square root out, and I'm left with x squared equals y plus 2, which is free from the radical. Then to get the y alone, I will subtract 2 from both sides. And I have x squared minus 2 equals y. And I can replace that y with like g of x, which will equal x squared minus 2. So this here is my inverse.